Our next cipher is named after its inventor. The so-called Vigenère cipher was developed in France in the 16th century by Blaise de Vigenère. An essential and highly practical tool for this cipher is the tabula recta, which was developed by a German Benedictine abbot, already in 1508. We will have a closer look at it later on. This cipher is now an example for a polyalphabetic substitution cipher. For this cipher, we first have to convert our plaintext alphabet into numbers. We do this by simply numbering the letters from 0 upwards. However, the numbering could also start by 1. The communication partners must agree on this beforehand. Moreover, it is common to write down an initial 0 for one-digit numbers to avoid any misinterpretations. This time, we want to send the message that there might be a treasure hidden by the lighthouse. We already write this message down without any spaces. Now, we convert this message into numbers by writing down the respective number from the second line. This means that for D, we write down 3. And also for I, we get an 8, as well as for G a 6. By the same method, we get the remaining numbers. As a next step, we decide on a key, which we also have to convert into numbers. We decide on Vigenère, and proceed as in the previous step. So far, we have converted our plaintext and key into numbers. In this step, we want to now actually apply the key to our plaintext. For the Vigenère cipher, the key is usually shorter than the message. Therefore, we repeat the key as often as necessary, even only partially. For the actual encryption, we can forget about the letters and only work with the numbers. We now add the numbers of the plaintext with the numbers of the key, namely each number of the plaintext individually to the one number of the key below it. However, we see that we are not completely done yet, when we have a closer look at our ciphertext. 5 numbers are greater than 25, which is the maximal number of our table. Hence, let's have another look at our table. Since Z was 25, we simply continue with A as 26. Looking at our ciphertext, we have to replace the values which are greater than 25 by the respective numbers from the first line. We start with 37, which the table tells us equals 11, which we write down. Analogously, 33 can be replaced by 7. We apply the same procedure to the remaining numbers. Note that what we did here equals a subtraction of 26. So finally, we have our ciphertext. Of course, this ciphertext could also be converted back into letters if desired. If you want to learn more, visit embedded-academy.com.